We're now jumping up to Chapter 11 to continue our discussion of hypothesis testing. And sometimes, instead of comparing to some known value or some claimed value, we want to compare two different populations. Like, for example, how do the mean cholesterol levels compare between men and women? So we have the group A, group 1 would be the men, and group 2 would be the women. Or how does the proportion of Republicans that support a particular issue compare to the proportion of Democrats that compare to a particular issue? So what we're going to be taking in this section is independent samples, and we're going to be taking two independent samples. So males versus females, Republicans versus Democrats. Two groups where there aren't any overlap. They have to be independent. In a later section, we're going to look at what happens when we have dependent samples, like a before and after situation, or where you're comparing identical twins, where there's some sort of dependency between the two groups. But here they're going to be independent. And we're going to be doing this for the difference between two means and the difference between two proportions. And today in 11.1, we're going to look at the difference between two means. The procedure, those 5 steps, is still the same procedure. So a couple details look different. What your hypotheses will look like is a little different. And the test that you use on the calculator, of course, is different. So the first thing you should do is state the hypotheses. So when you're comparing two samples, your hypotheses, you're not going to have to look for a value to compare it to. The null hypothesis when you're comparing two means is just mu1 is equal to mu2. And what that means is there is no difference between the two groups. And then the alternate hypothesis will either be there is a difference, not specifying one is greater than the other, just they're not equal. Or it could be that group 1 is greater, has a greater mean than group 2. Or it could be that group 1 has a lesser mean than group 2. And so I always like to write down what group 1 and group 2 are so that I can make sure my inequality is pointing the right way. So I might write down like 1 equals males, 2 equals females, just for an example. And then it's also helpful to keep in mind that if you're doing a right-tailed test, your test statistic should turn out to be positive. If you're doing a left-tailed test, your test statistic should turn out to be negative. If it's the reverse, it's likely your H1 is wrong, and that's what you should change. Okay, then you should state the test statistic. Now the test statistic, how you're going to find that with this type of test, it's a t-test. So you're going to be finding a value of t, and the test you use is test number 4 on the calculator. So when you have your HO is where you're comparing two means. That's how we know to use test 4. And it's called the two-sample t-test. We will not be doing a z-test with two means, only the t-test. And then from there, the rest of it's identical. You state the p-value, you get that from the test. And then you can make a decision. And the decision is made the same way that it always is. If your p-value is less than or equal to your significance level, alpha, then you reject HO. If your p-value is greater than alpha, you fail to reject HO. And then finally, of course, you have to state your very specific conclusion. Relating it specifically to the problem. And let's just take a real quick look before we do an example at what test 4 looks like on the calculator, because it does ask for quite a bit of information, and I just want to go through that with you. So we're going to go to Stat Test number 4, the 2-sample t-test. So like before, we have the choice between data and statistics. Usually you have the summary statistics. We're going to do examples of both types though. And so you're going to have 2 samples. So it's going to ask you for the sample mean from the first group and the sample standard deviation and the sample size, all from the first group. And then it wants the same information from the second group. And if they're giving you the summary statistics, this will be all provided to you. Notice that there's no value to put in. Like usually when we were doing this in chapter 9, we had a mu0. No such thing here because we're comparing 2 means. And then when you get down to the next to the bottom line down here, mu1, this is still going to match h1. So you're going to use the not equal if your h1 is a not equal, you're less than if your h1's a less than, and you're greater than if your h1's a greater than. And then for the pooled, there are 2 methods for doing this type of test. Some are where you pool the standard deviations and some are where you do not. We are using the method where you do not pull the standard deviations. So that should be highlighted no, just like mine is, and just leave it like that. There's no reason to ever change that. So keep it at no. And if I scroll all the way down, I believe the rest of it is the same. Then you just calculate, yeah. So I just wanted to point out that you keep your pulled at no. In fact, I think I'll write that down back here where we're doing the calculator. Pulled should always say no. Never change that. All right, so let's do some examples. So on page 519, we're going to start with number 10, and we're comparing low fat to low carb. It says, are low fat diets or low carb diets more effective for weight loss? A sample of 77 subjects went on a low carbohydrate diet for 6 months. At the end of that time, the sample mean weight loss was 4.7 kilograms, with a sample mean standard deviation of 7.16 kilograms. A second sample of 79 subjects went on a low-fat diet. Their sample mean weight loss was 2.6 kilograms, with a standard deviation of 5.90 kilograms. Can you conclude that the mean weight loss differs between the 2 diets? Okay, and there you can see here that the parts A, B, C, and D are just going to be our 5 steps. So you can ignore those parts when you do these problems and just do the 5 steps that you're supposed to do. So let's list the information from this. So I always state which group is which. So I'm going to let group 1, since they talked about that first, be the low carb group. And then we'll let group 2 be the low fat group. And let's just summarize what they found. So the sample of 77 went on low carb. So that's N1 is 77. And they had a mean weight loss of 4.7 with a standard deviation of 7.16. Okay, and then for the second group, it was N2 is 79. The sample mean weight loss, so X bar 2 was 2.6 with a standard deviation, so S2 was 5.90. And we're looking to see if there is a difference between the 2 diets. So we're looking to see if we're not saying is one have more weight loss or less weight loss than the other, just is there a difference. So we're going to use the not equal. And when we go to make our decision, alpha, they want us to use 0.01. Okay, so I went ahead and wrote down the 5 steps because those haven't changed. And by now I think you already hopefully know those. So let's just go through each of the steps. And by the way, I just wanted to mention here at part C, It says, how many degrees of freedom are there using the simple method? Because we're doing everything on the calculator, I really just want you to omit that. You don't have to worry about that. Just ignore that. So I left it on there so I could point out to you to ignore it when you're doing the homework. Okay, so for the hypotheses, our null hypothesis is always that there is no difference. So mu1 is equal to mu2. That's going to be your null hypothesis always when you're comparing two means, two independent means. And then H1, that comes from the problem. The problem says, does the weight loss differ? So it's going to be mu1 is not equal to mu2. So those are our hypotheses. And so now we're going to get the test statistic. And because we're comparing two means, that's when we know to use test number 4. So let's go to test 4, and here's everything. I wrote it down up here. This is everything that we're going to input into the calculator in a different order, but that's what we're putting in. So I'm already at test 4, so let me go back up to the top here. So for X bar 1, we had 4.7. For S1, we had 7.16. And for N1, it was 77. And then X bar 2 was 2.6. S2 was 5.90. And N2 was 79. And then we're doing the not equal option. We always keep pooled at no, and then we calculate. And from here, this is going to be like all the other problems we did. So my test statistic T, if I round that to 2 decimal places, that's going to round to 2.00. So T is 2.00. And then the p-value was 0.0477. And so when we go to make our decision, we'll put our p-value on the right, or on the left, I mean, and our alpha on the right. And when you make that comparison, there is no difference in place value until we get to the hundredths place, and 4 is bigger than 1. So my p-value is greater than my alpha, so that means we failed to reject HO. So we don't have the evidence to say that there's any difference between the two diets. So there is not enough evidence to conclude that the mean weight loss differs between the two diets. So as you can see, it's pretty much the same procedure. The hypotheses are different, and the test we use to get our values differs. Let's do another one. Now this one, we're going to do one where we actually have the data instead of the summary statistics. So it says a new post-surgical treatment was compared with a standard treatment. 7 subjects received the new treatment, while 7 others, the controls, received the standard treatment. And by the way, as we saw in the last one, the sample sizes do not have to be the same. Here they are. The recovery times in days are given below. And it says, can you conclude that the mean recovery time for those receiving the new treatment is less than the mean for those receiving the standard treatment? Use alpha equal 0.05. So when we go to make our decision, that's the alpha we're using. And it doesn't say anything in the problem. Technically, it should, because we've got small samples. They should be telling us something about it being a normal population, or it makes sense to use the normal distribution. We're just going to assume it's okay. Okay, so even though I don't have the summary of statistics, I still think it's helpful to write down which group is which. So we're going to let 1 be the treatment group, since it's listed first. But you could switch that around if you wanted to. And 2 will be the control group. And the question is, I'm going to write it like this. 1 is treatment, 2 is control. And the question is asking us, can you conclude that the mean recovery time for those receiving the new treatment is less than the mean for those receiving the standard treatment, which is the control group? This is new, this is standard. So we're doing 1 is less than 2. So when we go to state our hypotheses, HO, of course, it doesn't matter what the problem says. It's always mu1 equal mu2 for these type. But H1 is going to be mu1 is less than mu2. And had you chosen to label these the opposite way, where 1 was the standard treatment and 2 was the new treatment, you'd have a greater than. So that's why it's helpful to write down what you're doing. Okay, and then we're ready to get the test statistic, which will be T, and we're going to have to put this data into our calculator. So I'm going to switch over to my calculator, and we'll go into Stat Edit, first of all, and I'm going to clear out my list 1, and if I had anything in list 2, I would clear that out as well. So we're going to put the treatment group, which we called group 1, in list 1. So we have 12, 13, 15, 19, 20, 21, and 24. And then in list 2, we're going to put the control group. So we have 18, 23, 24, 30, 32, 35, and 39. Okay, and now when we go into stat test number 4, because we put the actual data in, not the summary statistics, we're going to highlight data. And you shouldn't have to input much. List 1 should say list 1. List 2 should say list 2. Both of your frequencies should be 1. This is the default, so you shouldn't have to change that. And then remember our H1, I've already forgotten what H1, I think it's a less than. So H1 is less than, so I need to pick the less than option. Pooled will always stay at no, and then calculate. And what it's going to do is get the X bar and the S's for you. It'll even list them, although we're not really interested in that here. So my T is negative 3.37. So T is negative 3.37. Notice how it turned out negative. That makes sense for my H1. And then our p-value is 0.0036. And so to make our decision, we're going to compare that to alpha, which is 0.05. So we have 0.0036 and 0.05. The tenths place has the same digit on both numbers, but the hundredths place has a 0 and a 5. 0 is less than 5. So my p-value is less than alpha, so that means we reject HO. We have significant results. And so our conclusion is just H1, that the mean of the first group is less than the mean of the second group. In other words, the mean recovery time is less with the new treatment. And sure, we can see that if you look at, your X bar 1 and your X bar 2. X bar 1 is 17.7 days. X bar 2 is 28.7 days. So we can see that it's less than, but just looking at those numbers doesn't tell us if it's significantly less than. And the hypothesis test told us that. So we can make the conclusion, yeah, it was definitely less for our sample, but we can now make the conclusion about the population that it appears to be less than that with the new treatment. It's significant. Okay, let's do another one. This one is on baby weights, and we have samples again. It says, following are weights in pounds for random samples of 25 newborn baby boys and baby girls born in Denver in 2011. Box plots indicate that the samples come from populations that are approximately normal. They really needed to say that on the last problem. They didn't. But that's just telling us that we're allowed to do the problem. Can you conclude that the mean weights differ between boys and girls? So differ, we're looking at a not equal. And I'm going to let group 1 be the boys and group 2 be the girls. And we're doing this at a 0.05 level of significance. So HO, of course, is that there is no difference. mu1 equals mu2. And then H1 is we're checking to see if there's a difference, so it's a not equal. So mu1 is not equal to mu2. And so what you're going to do to get your test statistic, which will be a t, is you're going to, and alpha was 0.05. To make our decision. So we're going to go to our calculator, and we're going to clear out list 1 and list 2 and put these values in. And so in list 1, put the boys, and in list 2, put the girls. And I'm assuming you don't need to see me input those values, so I'm going to pause my video, input the values, and then we'll resume. So you can go ahead and input your values as well. Okay, so once you have your data entered, which I do here, we're going to go to Stat, over to Tests, and select number 4. So the only thing that you should have to change is change it to not equal, which I already did, because we're doing a two-tailed test. So right here you should make this not equal and then calculate. And so from this output, we're just interested in the t and the p value. So t is 1.16. So 1.16. And then you can see the p-value turned out to be 0.2535. And so when we go to make our decision, we're going to compare that 0.2535 to 0.05. And you can see that it's greater. So we will fail to reject HO. So for our conclusion, there is not enough evidence. It's not significant evidence. So there is not enough evidence to conclude that. And then we were testing for a difference. And you can also look back at the problem to help you word your conclusion. There is not enough evidence to conclude that the mean weights differ between boys and girls. And I believe this is mean weights at birth, because they definitely differ later. Differ between boys and girls. I just have one last example. Let's look at number 18. It says the Pew Internet and American Life Project surveyed 2,227 adults in 2011, asking them about their texting habits. Among the men, the mean number of text messages sent per day was 40.9, and among the women, it was 42.0. Assume that 1,085 men and 1,142 women were sampled, and that the standard deviations were 56.5 for the men and 51.4 for the women. Can you conclude that the mean number of text messages differs between men and women? Use alpha equal 0.05 level of significance. So our alpha is 0.05. Okay. So they talk about the men first, so I'm going to let that be group 1, but you could certainly flip that around if you wanted to. And we're going to let group 2 be the women. And then let's summarize. We are going to need N1, X bar 1, and S1. And we're also going to need N2, X bar 2, and S2. Okay, so 1,085 men were sampled. 1,142 women. Among the men, the mean was 40.9 with a standard deviation of, do they tell us that? It's 41. Okay. All the standard deviations were 56.5 for the men and 51.4 for the women, and the women sent 42.0 text messages. So this right here is the information we need for the calculator. Okay, so for our hypotheses, HO is going to be there is no difference, so mu1 equals mu2. And H1, well, they're asking us, it says, can you conclude that the mean number of text messages differs? So we're going to be doing a not equal. Mu1 not equal to mu2. And so now to get our test statistic, we're going to use the calculator and go to test 4. And I'm just going to use my handheld calculator so we can have this information right in front of us. You do want to make sure that the first thing you do is switch it back over so that stats is highlighted, because we don't have the data. You know, this is over 2,000 and some pieces of data. We don't have the data. We're going to input the values. So X bar 1 was 40.9, S1 was 56.5, and N1 was 1,085. X bar 2 is 42.0, S2 is 51.4, and N2 was 1142. And then we want to keep it at not equal. Pooled needs to say no, and then calculate. And so you should get your t-value to be, your test statistic should be negative 0.48. And the p-value is 0.6314. And so when we compare the p-value to our alpha, we have 0.6314, which is obviously greater than 0.05, so we will fail to reject HO. And so our conclusion is there is not enough evidence to conclude that And like I said, I kind of like to let the wording of the question guide me in the wording of the conclusion. Can you conclude that the mean number of text messages differs between men and women? And so there is not enough evidence to conclude that the mean number of text messages differs between men and women. And that finishes this section up. So we have 2 more sections on hypothesis testing that we'll be looking at. We're going to look at when the samples are dependent, which complicates things a little bit. That's like a before and after. So a good scenario where you might see that is like cholesterol levels before starting an exercise program, and then you have the same sample of people, but you test their cholesterol levels after starting an exercise program. And then the final section we have to look at is testing the difference in proportions. So like percentage of men compared to percentage of women. And so those are the next 2 sections we'll be looking at.